This is A Different Perspective with Kevin Randle. A retired U.S. Lieutenant Colonel, Kevin Randle has been studying UFOs for nearly 50 years. Kevin has investigated some of the most famous UFO cases in the world and has been consulted for dozens of documentaries about UFOs. Considered one of the leading experts into the Roswell UFO crash of 1947, Kevin has written more than 25 books about UFOs, including the recently published Roswell in the 21st Century. Now, here is the host of A Different Perspective, Kevin Randle.
And welcome to this edition of A Different Perspective. I am the host, Kevin Randle. I'm joined by Dr. Abraham Loeb, Dr. Avi Loeb from Harvard, and I'll get to him in just a moment. Normally at this part of the program, I have some sort of a rant that goes on, and I just don't have anything that would be appropriate for the UFO program. So we'll avoid that and just bring the guest forward, I guess is what I'm trying to say. Dr. Abraham Avi Loeb is a Frank B. Baird Jr. Professor of Science at Harvard University, where he was the longest serving chair in the history of the astronomy department from 2011 to 2020, and where he directs the Black Hole Initiative and the Institute for Theory and Computation. The length of the sentence made me stumble. Sorry about that. He's a member of the President's Council of Advisors on Science and Technology, as well as the advisory board for the educational platform Einstein Visualize the Impossible. He also chairs the advisory committee for the Breakthrough Starshot Initiative and on the board of Physics and Astronomy of the National Academies, and serves as the science theory director for all the initiatives of the Breakthrough Prize Foundation. He's the author of 5 books and 800 scientific papers. Now, 800 scientific papers is kind of impressive, I think. And I've lost my place there. The 800 papers. He's an elected fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. In 2012, Time selected Loeb as one of the 25 most influential people in space. He lives near Boston, Massachusetts, and his book that became a bestseller was cleverly called, I think, The Extraterrestrial, and he's an advocate for an alien artifact in the solar system. Dr. Loeb, welcome to A Different Perspective.
Thanks for having me. And I should say all these labels do not mean too much to me. I'm basically following my childhood curiosity. So I see science as a privilege of maintaining your childhood curiosity.
Well, that's a quite impressive list of accomplishments there. No question about that. I understand you were in the Israeli army at one point.
Yeah, when everyone at the age of 18 is drafted to the military, and I had 2 options: either to become a soldier or to be recruited to a program where I could pursue physics and mathematics. I was mostly interested in philosophy, actually, at a young age. But this program actually allowed me to go through all the army sections. We parachuted. I parachuted 3 times. We drove tanks. So I basically was in all the military component sections, and then I did my PhD in plasma physics, and I initiated a project that was supported, the first international project to be supported by the Star Wars initiative of President Ronald Reagan, and that brought me, we got a few $1 million a year for the project. I was leading the theoretical work, and I collaborated with an experimentalist. And in one of the visits to Washington, D.C., I also visited Princeton, where they offered me a 5-year fellowship at the Institute for Advanced Study under the condition that I'll switch to astrophysics. And that led me to astronomy and astrophysics. And then I was offered the faculty position at Harvard University. And once again, it's an offer that I could not decline, just like in The Godfather. It's an offer I couldn't refuse. But and once I became tenured at Harvard, I realized that even though it was an arranged marriage by circumstances that I got into astrophysics, I'm actually married to my true love, because there are lots of philosophical questions that we can address using the scientific method in astrophysics.
Well, I was going to say, you said you parachuted 3 times, and I was a helicopter pilot, and we never jumped out of a perfectly good airplane. So
it was interesting. And actually, in the first 3 months in the military, I remember sleeping 7 hours a week. We were in the we were trained as paratroopers, and I was very capable physically speaking. I was at the top 3 people in sports in my high school, and so it was easier for me. But nevertheless, it was very difficult training that we went through. And the one thing I learned from that experience is, I remember some of the officers saying, sometimes a soldier needs to put his body on the barbed wire so that others can pass through. And I feel like that when I see negative tweets on the current research that I'm doing. I feel that I'm trying to pave the way for the next generation of young scientists so that they will be able to speak freely on this subject.
Well, let's go there. We have this object that came into the solar system I guess a couple of years ago, and you came out in the spring and suggested that it was artificial. And it's for the benefit of the audience, of course, where do you believe it originated, or what direction it came from? Did it make a turn in the solar system and slow down and then speed up? Give me a little bit of background on that.
Yeah, so the details about this object called Oumuamua, the details are given in my book, Extraterrestrial, that came out 7 months ago, January this year. This object was the first one that came from outside the solar system that we spotted near Earth. And it looked nothing like we have seen before within the solar system. Didn't look like a comet, didn't look like an asteroid. There was no cometary tail around it, no gas or dust. And then as it was tumbling every 8 hours, the amount of sunlight reflected from it changed by a factor of 10. And that meant that the object has a very extreme shape, most likely flat, pancake-like. And then it looked as if there is a force pushing it away from the sun, acting on it in addition to the force of gravity. Since there was no cometary tail, no outgassing, it couldn't be as a result of the rocket effect. And the only possible explanation that came to my mind was the reflection of sunlight, because this force declined inversely with distance squared, just like you expect from the reflection of sunlight. And as it turns out, in September 2020, there was another object that exhibited an excess push away from the sun by reflecting sunlight with no cometary tail. It was given the name 2020 SO. It was discovered by the same telescope in Hawaii that discovered Oumuamua in 2017. The name Oumuamua means a scout in the Hawaiian language. And this second object, 2020 SO, the astronomers that discovered it realized within a few weeks that it actually came from Earth. It's a rocket booster that we launched in 1966 in a lunar lander mission. So we could tell, just by looking at how it moved, we could tell that it's not a rock, that it's very thin. In fact, we know that it had thin walls because we produced it, and that's why it had a large area for its mass. The question is, who produced Oumuamua? And of course, one way to figure out the nature of Oumuamua for sure, or objects like it, would have been to get a high resolution image, because they say a picture is worth 1,000 words. In my case, a picture is worth 66,000 words, the number of words in my book, Extraterrestrial.
Well, I noticed there was pushback by the scientific community. You suggested it was artificial, meaning it was made by somebody probably hundreds of thousands of years ago. As it was approaching the solar system, didn't it have speed that would have been close to light speed or relativistic speeds and slow down as it reached the solar system, or can we backtrack that far?
No, it was mostly moving under the influence of gravity, and then there was this additional force acting on it as a result of reflection of sunlight. But this object had several anomalies, several peculiar properties. So in addition to the fact that it had no cometary tail, so it couldn't be a comet of the type that we have seen, and it also had a very weird shape, most likely flat shape, and it was pushed by reflecting sunlight. In addition to those, it also came from a very special initial state, which is it was at rest in the so-called local standard of rest. So the local standard of rest is the frame that you get to when you average over the random motions of all the stars in the vicinity of the sun. Each star has some motion relative to the others, sort of like cars moving relative to the center of a city. But then you can go to a parking lot that is at rest in the frame of the city. And that's called the local standard of rest. And Oumuamua was at rest in that frame, which is very unusual because only 1 in 500 stars is so much at rest as Oumuamua was. So it couldn't have come from any of the nearby stars because they are moving relative to that frame, and it would have inherited their motion. It was like a buoy sitting at rest on the surface of the ocean, and the solar system, like a giant ship, bumped into it. And it's very unusual to find the first object in that frame. And the question is, what was it doing in that frame? What was its purpose? And I can think of different explanations. One is that it's a member of an array, a grid of objects that are placed in the frame of the Milky Way galaxy, in the local rest frame, such that it's being used for navigation purposes. These are just like road posts that allow spacecraft to figure out where they are. But there could be other explanations. We just don't have enough information about this object. But it's clearly a very peculiar object because of all the reasons I mentioned.
So the scientific community kind of pushed back against your theory of being artificial, suggesting it might have been I think a nitrogen iceberg type thing, which would have had some of the similar aspects that you talked about. And I think you rebutted that. What was your rebuttal to them?
Well, there were several scientists that tried to explain the anomalies of Oumuamua as coming from a natural origin. And the first suggestion was maybe it's a hydrogen iceberg. Maybe it's a chunk of frozen hydrogen so that when it evaporates like a comet, we don't see the hydrogen because it's transparent. And the problem with that, we wrote a scientific paper about it, is that hydrogen evaporates very quickly. And so it won't survive the journey through interstellar space. And that makes this model not very plausible. Another suggestion was maybe it's a nitrogen iceberg, a chunk of frozen nitrogen chipped off the surface of a planet like Pluto. The problem there is the mass budget. There is not enough nitrogen available in the interstellar medium to account for enough chips such that you would get one of them as Oumuamua. You discover them by the pan-stars that looked at the sky for a few years and found Oumuamua. So the mass budget is a serious problem and challenge that makes this scenario not very likely. And by the way, both a hydrogen iceberg or a nitrogen iceberg are things we've never seen before. So the people that suggested them imagined something we've never seen that is made in other nurseries that do not resemble the solar system, because in the solar system, we don't see such things. So the assumption is the first object we see is coming from nurseries that must be very common because that's the first object we see. And they make objects that are very different from the ones being made in the solar system. And, okay, well, let me just finish. There was a third suggestion that it may be a cloud of dust particles that is 100 times less dense than air. And there the challenge is that it would not maintain its integrity. When it gets close to the sun, it will be heated by hundreds of degrees and will just not be able to survive. And so all of these suggestions involve something we've never seen before. And my point is, if it's nothing that we have seen before, we need to consider the possibility that it's also artificial in origin.
Okay, well, we're going to have to take a quick break here because we're running up against the clock. When we come back, I think I want to talk about your Galileo project, which I think is an outgrowth of this discovery and what that entails and what that's all about. And I think that'll be something we need to do. I'll have additional information up on my blog at www.kevinrandle.blogspot.com. And take a look at there. You'll find some interesting stuff about UFOs as well. You are listening to A Different Perspective on the X-Zone Broadcast Network, and we'll be back right after this, so please stick around. And I am back with Dr. Avi Loeb. We're talking about artificial objects in the solar system, from outside the solar system, that sort of thing. And we are practicing social distancing because we are not in the same place at the same time, which I think is just wonderful of us. When we went away, we had kind of explored, I guess, the idea, or why we thought, or why you thought that the Mumu was an artificial object as opposed to something naturally formed. And I think this gave rise to this idea of the Galileo project, which you and a number of your colleagues have announced. Tell us a little bit about the Galileo project.
I'd be glad to. Speaking about social distancing, I should mention that I wrote a Scientific American essay. I write one every week about social distancing on a cosmic scale. You can imagine that an advanced civilization might decide not to interact with lower level civilizations because it will degrade their quality of life. So they may close themselves in a cocoon and just have everything they need. How do we find about them? What they're doing? They must deposit some trash according to the second law of thermodynamics. So just like those investigative journalists that go through the trash cans of celebrities in Hollywood in order to find about their private lives, we could find trash that they sent into space. And from that, infer that they exist and learn something about their private lives. So just a comment about social distancing that may exist in the Milky Way galaxy.
When you talk about going through their trash, I'm sure you're talking about the electromagnetic signals being sent out, such as we radiate from Earth.
No. So for 70 years, the search for extraterrestrial technological civilizations focused on looking for signals. I think it's the wrong approach because it's just like trying to have a phone conversation. You need the counterpart to be alive at the time that you're having the conversation. What I'm talking about is like archaeology, looking for relics that were left behind. The civilization might not be around anymore. It might have perished. You know, it's not clear that we would survive more than a few centuries from now. So there is a relatively very narrow window of opportunity to interact with us, just a few centuries out of the age of the Earth, which is 4.5 billion years. That's a very narrow window. And if anyone tries to communicate with us, they have to be alert just for this very narrow window so that we will be receiving their signal and they will receive our signal. So a much better approach is looking for physical objects that were sent into space, like we sent Voyager, New Horizons. And, you know, currently we're developing artificial intelligence systems that will drive cars, that in the future will make medical decisions. So I can imagine an AI system sent into space, sort of like sending your kids to the world. You can train them early on so that they follow your goals, and then they learn from experience and they're completely autonomous. You don't need to send them any guidelines because the distances between stars are huge and it may take millions of years for them to reach nearby stars. So you just send those systems and they basically follow your guidelines and do it autonomously. And if we can imagine such a future within a decade or two from now, because we are developing AI systems and we have the ability to send spacecraft, it's quite likely that a civilization that predated us by 1 billion years did that already. And, you know, most stars formed billions of years before the sun. So this may be our reality. And if you imagine those AI systems sent 1 billion years ago with a 3D printer, they could replicate themselves and produce many copies, and they may fill up the Milky Way galaxy, including the solar system. Any habitable region around a star may have a probe of this type. And the question is whether we live in such a reality. And the only way to find out is not to talk philosophically about the subject and try to argue about probabilities, but rather to look through telescopes. because we don't want to repeat the mistake that was made by philosophers during the days of Galileo. They refused to look through his telescope, and they said, we know the answer, the sun moves around the earth. And of course, that maintained their ignorance, but it didn't change the fact that the earth moves around the sun. And poor Galileo was put in house arrest. So that's why we announced the Galileo project. And I would have been delighted to have Galileo Galilei as a honorary member of our project. And this project was announced just a month ago as a result of a few wealthy individuals that came to the porch of my home with questions about my book, Extraterrestrial, and offered a total of $2 million in support of my research program. And that was sufficient for me to assemble a team of scientists, 24 of them by now, that mostly astronomers, that will be engaged in scientific research. And there are two primary objectives to the Galileo project. One is to find more objects like Oumuamua and get a camera on a spacecraft that will intercept their trajectory and get a close-up photograph so that we can tell what they are. And then the second aspect is the unidentified aerial phenomena that appeared in the report of the intelligence agencies to Congress on the 25th of June, which also prompted the Galileo project. So we want to build telescope systems on Earth that would monitor the sky in a scientific way, not a camera on a jittery cockpit of a fighter jet that we have no control over, we don't want to look at classified data, because then I would lose my freedom as a scientist to speak about it. So we want to basically assemble our own open data using the scientific method by using telescopes, several of them in each system, so that we can monitor the motion of any UAP in 3 dimensions, big enough telescopes so that we can get a high resolution image of the UAP. I have a Scientific American essay talking about getting a megapixel image of a UAP that will tell us, if you get a megapixel image, for example, of an object the size of a person at a distance of a mile, you can get that with a telescope of a diameter of 1 meter, and then you can resolve the head of a pin on that object. You can tell whether it has a label made in China, made in Russia, or made on exoplanet X. If it's made by humans, it's of no interest to me as a scientist. If it's a bird, it's also of no interest to me because I'm not a zoologist. But if it's something else, I would be very interested in what it looks like. And that's what the Galileo project will look into. And we have a team of astronomers that are currently putting together the components, off-the-shelf components of a telescope system. And then we will make many copies of that telescope system and put them in different locations. And, the technologies that are available now for us are much better than those that were available to those fighter pilots that reported 20 years ago about some unusual objects. So,
well, let me interrupt here because I do have a question. What's the reaction to SETI to this project? Are they on board with you, or are they kind of opponents?
Well, it's interesting because many of the members of the SETI community had a problem with UAP or UFOs in the past. And of course, it may be a mixed bag that many of the reported objects have a mundane explanation, but I should emphasize that it's sufficient to have one object which was not produced by humans for this to make a huge impact on the history of humanity, because we don't need all of the objects to be unusual. It's sufficient to have one. And so I don't care if 99.999% of the reports have mundane explanations. So the idea is to get scientific quality data so that we can be convinced that something is not human-made, it's not natural.
But the SETI program is listening for.
Yeah, the SETI program focused mostly on searching for signals, mostly radio signals, but also signals in visible light. As I mentioned before, I believe that a better approach is to look for physical relics, objects, perhaps driven by AI or something else. But
I understand that. I'm just wondering if SETI is pushing back against this because you're kind of an opponent to them, suggesting that the search for electronic signals from them isn't really going, all it's going to do is tell us that they're out there. It's not going to do the same thing that you're doing with them.
Well, I see it as complementary. I'm not saying, I'm not opposing what they're doing. I'm just saying there is another way to go at this question of are we alone and whether we are the smartest kid on the block. I'm just saying there is another way to figure this out, which was not examined scientifically in the past. And there are some SETI people who are pushing back. But there was a very favorable essay written by Seth Shostak from the SETI Institute, basically saluting and encouraging the Galileo project. And, I have an advisory board that includes a lot of distinguished scientists, including Seth himself. Now, there are people that have expressed reservation about the Galileo project, but frankly, I don't see any negative aspect to it because we are using funds that came from private donors. These funds were not used for any other scientific project before, so we're not taking away money from existing projects. And moreover, there is a huge level of support, enthusiasm. I got thousands of emails from young people who would like to contribute to the project. So it's a win-win proposition to look for evidence and have a scientific approach to this subject. I don't see why anyone would have a problem with getting evidence based on funds that were not used for any other purpose.
Well, I was just thinking that their approach is just listening for signals, and you're taking a more proactive approach, I think, than what they're doing. And I know that the other thing is, as a writer, when I have published a science fiction novel and we go to science fiction conventions, that there are other science fiction writers there who feel you've taken money out of their pocket simply because you've published a book and they didn't get that opportunity, even though they wouldn't have had that opportunity no matter how you slice the bread. So
right.
You're not taking money from them.
Well, I offered the SETI people and others to join me in this endeavor. I'll be glad to collaborate with them, but for many years, there was dismissal and ridicule of the unidentified aerial phenomena and or UFOs, as they were called before that. And as a result, they have difficulty accepting a scientific project aimed at clarifying the nature of these objects. And as I said before, science is not about prejudice, it's about evidence. It should be guided by evidence. And the reason I announced this project is that there was this Oumuamua interstellar object that looked weird, and also there was the report about unidentified aerial phenomena by the government, and these are the UAP that were mentioned were detected in multiple instruments. So to me, it looked intriguing enough for scientists to be engaged. And I should say, the NASA administrator, the head of NASA, Bill Nelson, who saw also the classified data as a senator, argued that this is a serious matter that scientists should be engaged in. And former CIA directors, Brennan and Woolsey, also spoke about it as a serious matter. And former President Barack Obama acknowledged that as well. And, if these people saw the classified data and they speak about it as a serious matter, I think the scientific community has an obligation to figure out the nature of these objects. And that's what we are doing in the Galileo project.
But you have a UFO UAP segment to look at. You're looking at that sort of thing. I want to explore the UFO just a little bit further with you when we come back, because I think there's a history in the UFO phenomena that's important. For example, the Condon Committee, which was the University of Colorado study in the 1960s, suggested there was no national security implications and nothing of scientific value could be learned by studying these UFO reports, which is a preposterous conclusion for them to come to, but it was based on what the Air Force wanted them to find. And there's documentation to show the Air Force told them what to find for their investigation. So I want to kind of explore that a little bit with you here in a moment. And of course, there's Dr. Donald Menzel, who was a Harvard astronomer in the 1960s, who just chafed at the idea of UFOs and offered multiple explanations for UFO sightings, making the stuff up, and it was clear that he made the stuff up. Of course, then we can go to John Mack as well, but that's something else. I've got to take a break here. I've rattled on a little bit longer. You're listening to A Different Perspective on the X-Zone Broadcast Network. There's many fine programs about the paranormal to be found at XZBN.net, so take a look at those listings. My favorite happens to be A Different Perspective, and we will be back right after this with Dr. Avi Loeb. And I am back with Dr. Avi Loeb. We're talking about Oumuamua. We're talking about artificial intelligence. We're talking about the Galileo project. And we were talking about UFOs when we went away. But first, I must say it is the XZBN.net, not what I said before. I was watching my clock count down and got caught up in the syntax of the situation. When we went away, we just touched a little bit on the UFOs. And I know that when you and I have communicated before about looking at the history of the UFOs, and you didn't want to get caught up in that mess. And I understand part of that because the research has been pretty sloppy. The conclusions have been very biased. The documentation has not been properly certified. But I also know that when I was studying for my PhD, one of the first things we did was a literature search. And you'd look at what went on before you. And I'm thinking that there might be something of value in looking at some of the old UFO reports, especially those that where the craft interacted with the environment. For example, in Level Land, Texas, where the object stalled car engines.
Right. So,
and I wondered if you thought about maybe communicating with some of the UFO committee, which would not take money from the project, but to get a sort of an unbiased history of the UFO phenomenon. It might be of assistance to you.
So we are not historians, we are astronomers and scientists, and the goal of the project is to assemble new data on which we have full control in terms of the quality of the data, state-of-the-art instrumentation, because science is about reproducibility of results. Another way to think of this is if you tell a kid what the truth is, the kid would not necessarily listen to you. The kid would like to figure it out himself or herself. And sometimes the kid gets bruised in that process, but it's a learning experience. And, science is a learning experience. And as a scientist, I would like to get my own data so that I know exactly how the data was taken. I don't want to look at past data that was not of the quality that would make it scientific, because, unless it was reported in a scientific paper. And of course, we will look at the scientific literature, but a lot of the reports that you're talking about are either eyewitness testimonies or based on, fuzzy images or reports on YouTube that are not to the quality of science, because we didn't have full control over the instruments that documented these reports. I'm not saying that they are not necessarily indicating objects that are of great interest. I'm just saying the data is not good enough. And so the way to make progress is not through nostalgia, not by going to the past and starting to argue and trying to declassify things the government has and talk about what happened in the past and so forth. This is not the right way to make progress. The right way to make progress is get much better quality data, because if this phenomena, if these objects exist, they should exist also in the future, and we should be able to find them. We're not talking about a one-time miracle. Science does not accept one-time miracles. If there is a phenomena in nature, when you reproduce the circumstances, you should be getting the same kind of evidence. And this time around, we will use the best equipment that we have at our disposal, that we will purchase, and we will use the scientific method. So we will make the data open and transparent and of high quality, and we will analyze it in a clear way, and we will publish scientific papers about this data. So for the first time in the history of this field, we have a team of scientists engaged using the best instrumentation that we can buy to approach this subject. And rather than reminisce about discussions of the past. We want to get better data so that we can convince ourselves that there is something out there that cannot be explained by human-made objects or by natural phenomena. And the way to figure out that is to get better data than what was obtained in the past. I'm not saying that there wasn't interesting data obtained so far, but I'm saying it was not of the quality that we need to convince the scientific community. So we are embarking on that. And of course, as we get data, you will see it, and we will report about it in the scientific literature. So I want to bring this subject to the mainstream of science rather than the situation right now where scientists ridicule it and when the public is left to speculate about it. That's not a healthy situation. And, I think it went over a certain threshold where the government, a very conservative organization, discussed it. And it's now the duty of scientists to clear up the fog.
I understand that. What I'm suggesting here is there may be clues in some of this old data. For example, you talked about repeatability. There was a fellow named Ted Phillips who gathered landing trace case information, about 4,500 from around the world. Granted, a great number of them were just landing traces that had no object seen with it. But he also found out that if you told him the landing gear impressions in these landing traces, he could tell you what the object looked like, which sounds like a little bit of reproducibility. I'm only suggesting that there may be clues there that might be of benefit to your project with the electromagnetic effects and that sort of thing. And yes, granted, the information has been poorly gathered and that sort of thing, but I'm thinking that maybe this historical aspect may provide some clues for you guys what to look for.
Oh yeah, I mean, in terms of deciding where to put the telescopes, we are obviously looking at the past reports, and in figuring out how many telescopes to use, how many telescope systems to use, we do pay attention to the reports and the rate of incidence and so forth. But I should say what we are looking for is clear evidence that cannot be disputed. And you fully understand what it means. It means getting a megapixel image of an object where you can see the screws, where you can see the label, where you can see that there are buttons that you can press. It's not a fuzzy image that we can argue forever what it means. It's actually a high resolution image of the type that you're seeing me right now that can tell you that I'm a person. Okay, so that's what we are after. Something that is not disputable, something that was collected by instruments that we have full control over. It's not a cell phone camera that is not optimized for that purpose, that was held, and looking at an object at a distance of a mile, and therefore the object appears fuzzy. We are not in the, 1,000 cell phone cameras will not be equivalent to a 1 meter telescope that gets you a megapixel image of the same object. So because 1,000 cell phone cameras will, all of them would give you a fuzzy image of that object because they have a very small aperture in the camera. So you can't get a high resolution image irrespective of how many cell phones you use. They just don't provide that. You need a large aperture to get that high resolution image. So my point is, we need to use the best instrumentation that we have access to and get scientific quality data and write scientific papers that demonstrate without a doubt that we are dealing with an unusual object. And otherwise, it's always possible that we have seen a human-made object, that we have seen a natural phenomena. And that's what we are trying to clear up. And rather than engage in nostalgia about past reports, let's just get the best data we can. Nowadays, we have the funding, we can purchase the instruments, and we can get the data. So why argue about it?
Well, I was going to say, I think we're kind of talking across purposes here, because I'm not suggesting anything other than maybe there'll be some clues hidden in the UFO data that's been gathered in the past.
Well, if there were clues, that's not it's the job of those that collected these clues to convince everyone, and apparently they're not convincing everyone.
Well, I could argue, and I don't want to argue the point, but I could argue the point that part of the problem had been the government clouding the issue by saying these things do not exist and all of that. And I understand that we don't want to really go there, but I'm just saying we could make that argument.
But we can make a lot of arguments. But my point is, it's not about arguments. Why argue about it? Waste energy, time about things that we need to argue about. Why not just get good data that we don't need to argue about, such that everyone will be convinced? You know, it's just like convincing a jury. You go to a courtroom and you can argue forever. This person said that, the other person said something else. You can argue forever. But then if a detective brings clear evidence to the table, the jury would be convinced. So the point is, why argue forever? I mean, that's not the right approach to resolve the matter. The right approach is to act like the detective, to collect the very best data that we can collect. Now, if you tell me in the future, such data will never be found because it was a one-time phenomenon, that's something that happened and will never happen again, like, you know, miracles that happen in some religions and so forth, then it's not part of science, because science is about reproducibility of evidence. The fact that you can see the same thing again and again and get much better evidence on it. But if you claim that it's a miracle, then I cannot say anything about it.
Yeah, you can't refute that when you come down to the, well, it's a miracle and it's not going to be reproduced. I understand that. It was just my thought was simply that there might be something of value by looking at the past, not engaging you guys, but just
yeah, but my point is, if it was of clear significance that convinces anyone that looks at it, then everyone that looks at it would have been convinced, right? So why isn't the public convinced? Why isn't the jury, convinced? Because the data that was released, I'm not saying the government may have data that would convince people, but what we have seen so far is not convincing. And frankly, I don't want to look at classified data because that would limit my freedom as a scientist. So we want to, the sky is not classified. You know, astronomers look at the sky all the time. So we should be able to look at the sky with good instruments and collect the data that we need.
You're saying also that the Galileo project, the Oumuamua, was not a one-off, that there's other objects like that out there.
Yeah, because when you go to the kitchen and you find an ant, you usually get alarmed because you know that there must be many more ants out there if you survey just a small region of the kitchen cabinet. And the same is true for the discovery of Oumuamua. You know, the Pan-STARRS telescope that found it was surveying the sky for a few years, and it found Oumuamua, roughly the size of a football field, within the orbit of the Earth around the sun. And that means that if it will continue to survey for a few more years, it will find another one. And there will be a telescope, an observatory that is far more sensitive than Pan-STARRS, coming online within a couple of years. It's called the Vera Rubin Observatory in Chile. And it could detect objects like Oumuamua once per month. If they come into our region, our region around the sun, if they arrive here randomly. Of course, if Oumuamua was a one-time event that will never happen again, tough luck, we will never find another one. And that would make it even more unusual because it's not random. But on the other hand, if you make the simple assumptions, just like you make in the case of finding an ant in the kitchen, then there should be many more found in the future. And what we need to plan for is when we detect another one that doesn't look like a comet or an asteroid, then we should send a spacecraft with a camera that will intercept its trajectory and take a close-up photograph. Just like the OSIRIS-REx mission that took a close-up photo of the asteroid Bennu and actually landed on it, and they will bring a sample from it in 2023 to Earth. We can do the same thing with an object like Oumuamua. Imagine landing on it and pressing the buttons on it.
So from what you're saying is, if I was a civilization many, many light years from Earth and I wanted to explore my section of the galaxy, I would send out lots of these sorts of things geared with artificial intelligence to kind of replicate themselves as they move through the universe, and they're moving at sublight speeds. Exactly. So with the closest star system, Proxima Centauri, or the Alpha Centauri system, 4.1 light years away, it would take many, many thousands of years for it to get from there to Earth.
Yeah, it would, with chemical rockets, it would take 50,000 years, roughly the time that elapsed since the first humans left Africa. So if we were to send the New Horizons or Voyager towards Proxima Centauri, we should have sent it when the first humans left Africa for it to arrive.
Let me interrupt there because I'm getting up against my break here. When we come back, we'll explore that a little bit better of how this might work. Once again, I'm going to say there's many fine programs about the paranormal on the X Zone Broadcast Network at xzbn.net. Get it right this time. We will be back right after this with Dr. Avi Loeb talking about artificial intelligence, so stick around. I am back with Dr. Avi Loeb. We're talking about, I guess, a way to explore the galaxy. I'm not sure the universe is, we're going to be able to do the universe because the distances are really vast. Star systems are quite a long ways away, but other galaxies are just hundreds of thousands of millions of light years away. I'm thinking of the Fermi paradoxes. If the galaxy has other intelligence life out there, where are the colonists? I guess that type of thing. You're suggesting, I think, an explanation for the Fermi paradox is they wouldn't be colonizing, they would be sending out probes to kind of look around to see what's going on out there. How do they get the information back to their original civilizations then?
Oh, they don't necessarily, but as I mentioned before, AI systems can be thought of like kids, right? You train them early on and then you send them to the world. And they can be autonomous and they pursue your goals if you educate them well enough, right? If your kids disobey your principles, then of course you cannot trust them. But the kids will survive much longer. They would outlast you. And you can think of the AI system sent to space as representing us, but being completely autonomous. And it's not about sending information back. It's about pursuing your goals. So you have to define your goals. If your goals are to get to planets and use the resources there, or figure out what's going on there for your own purposes, those systems will go there and do it. Now, there is no point in communicating back any information because it takes a huge amount of time. Even for light to cross the galaxy, it takes tens of thousands of years. So, that's a very long time, and nobody has the patience to wait that long just for a signal to cross the galaxy. So my thinking is that these probes are sent out, well, for various reasons. One is that, it's sort of like interstellar monuments that you send. People want to leave something behind, right? So you want to leave something. So nature allows you to leave your DNA behind in the form of your children. Okay, that's one. But if you want to leave some meaning about what you've learned through your life, then you want to leave something beyond your children behind. And if you go, for example, through the halls of universities, you find administrators, deans, or presidents that left behind a statue or left behind a picture of themselves, as if, that would outlast the decay of their body. And, we see those pictures, but, it's not really physical objects that last for very long, because I think actually writing books or writing music could survive longer, but eventually everything on Earth will get destroyed by the fact that the sun will heat up and boil off all the oceans within 1 billion years. So nothing of what we produce as monuments, as relics of us, will survive beyond 1 billion years from now. And if you want to leave something behind that really represents yourself, you would send it into space. And you could send an AI system that carries some kind of a flame of your consciousness today. And that would represent you. So that may be one reason to send things out. And, if we are thinking about it, maybe others thought about it 1 billion years ago, and now it's filling up the Milky Way galaxy. And
Well,
another is,
let me ask you this. So we have Oumuamua coming through our solar system. There's an AI on it. We recognize civilization on Earth. Wouldn't that then trigger some kind of response from this artifact to say, "Hey, we were here once," or something like that?
yeah, if it's functional, right? And now the question is, how many pieces of trash are out there compared to those that are functional? Because after a while, the instruments may stop working and may not be repaired, and it will be just like defunct plastic bottles that you find in the ocean. They are not used anymore, but they are trash that they collected on the ocean surface. And so the question is, how many functional devices are out there compared to just things that are floating around? And of course, we need to get more data on those things, and we need to search. The thing is, the scientific community didn't really engage in such a search at all. And the Galileo project is really the first funded project, scientific project, to search for such things. And I think, what the scientific community did in the past was a self-fulfilling prophecy. It basically said, we need extraordinary evidence before we even engage in that discussion. And my point is, you would never get such extraordinary evidence if you're not searching for it. So it's a self-fulfilling prophecy, and there was no funding for this. There was funding, for example, to search for the dark matter, particles that we've never seen before. And for 40 years, we've been searching. We didn't find the particle that makes the dark matter. And that was considered part of the mainstream in science. It was also a search in the dark. So if we are searching for dark matter that would have very little influence on our daily life, why wouldn't we search at the same time also for relics of other civilizations? Because all we are saying is, we exist, and conditions are very similar on tens of billions of planets in the Milky Way galaxy alone. And therefore, let's search for things like us out there. That's not a very speculative proposition. It's quite natural for us to do that.
I agree. I think it's a wonderful project. I'm always looking for evidence of extraterrestrial civilizations and extraterrestrial life. So I mean, that's an important thing to do. And I think it's great that the scientific community has moved beyond the point where, well, these things don't exist, therefore they can't exist, therefore they don't exist, as opposed to, well, maybe they do exist, maybe we ought to take a look for them.
Well, it's not the scientific community that moved beyond this point. It's my research group that moved beyond this point.
Well, a small segment of the scientific community is now engaged in this search. Although you could say the same thing about SETI having engaged in this with Frank Drake and his OMA project, Project Ozma, so long ago, moving a little bit beyond that, looking for evidences of other civilizations. You've taken it to the next step, and I think are moving in a direction to find actual physical evidence that would demonstrate this beyond a shadow of a doubt.
Physical objects. And, the experience could be similar to a caveman that is presented with a cell phone. The caveman is used to playing with rocks all of his life. And when he sees the cell phone, he would say, oh, it's just a shiny rock. And that is pretty much the response of the astronomers to Oumuamua. It's just an unusual rock of a type that we've never seen before. That's what the caveman would say about a cell phone. But then it's a beginning of a learning experience, because if the caveman presses a button on the cell phone, he would realize that it can record his voice. And if he presses another button, it can record his image. And that would make it clear to the caveman that this is not a rock. And I think for us to get that sense that Oumuamua is not a rock or some other object, and a UAP is not a natural or human-made, we just need better data. That's the beginning of a learning experience.
And the Galileo project is a search for that evidence.
Exactly. I would love to press a button on such an object that doesn't behave like a rock.
Well, I was thinking the same thing, that if you manage to get there and press the button and open the thing up, that the...
Yeah, because by the way, it could be worth a lot of money if we can import that technology to Earth, if it represents our future. And if
we can understand the technology.
Yes.
The problem with the caveman is he doesn't understand the technology, but we do. And if we found something that advanced, we may not be able to push the button. There may not be a button to push. There may be some other way to gain the access.
That's true. That's true. Yeah. It may look like magic to us. Yes.
That's Arthur C. Clarke. Any advanced technology would certainly look like magic.
Yeah, I would make Arthur C. Clarke definitely a member of our project. I should say an anecdote about the project. So the project was called after Galileo. And then a colleague of mine, a historian at Harvard, at the Harvard History Department, named Erez Manela, pointed out that Galileo, the name, is derived from the northern part of Israel, which is called Galilee. And actually, when I mentioned it to the research team of the Galileo project, someone pointed out, actually, Galilee means a cylinder in Hebrew. I should have known that because that's my mother's tongue. And indeed, Galilee means a cylinder. And then when you think about it, that was the shape of Arthur C. Clarke's Rama in the book Rendezvous with Rama. And also, it's the shape of the object 2020 SO that was discovered in September 2020 that I mentioned before, the rocket booster from a lunar lander that was sent to the moon in 1966 and was discovered by the Pan-STARRS Observatory. And also Oumuamua itself had a very extreme shape. So it's an interesting coincidence that the name Galileo means more than one thing.
Well, I was going to also suggest a number of books have been written about contact with alien civilizations, but oftentimes the scientists go to the science fiction writers to get kind of an insight into their way of thinking outside the box. Have you thought about bringing on, I know Joe Haldeman is at MIT. I don't know if he still teaches there, but he did as a science fiction writer of some note. Have you thought about maybe engaging a couple of science fiction writers to think outside of the box, although you're doing a good job yourself?
Oh, no, I mean, obviously, I'm happy to discuss and interact with them. And, you know, over the past 7 months after my book, Extraterrestrial, came out, I had almost 1,200 interviews, back to back, almost every day, from 8 a.m. till 7 p.m. And some of them were with science fiction writers, and some of them were with artists. And yeah, the importance of science fiction is that it expands our imagination. I have a problem with storylines that violate the laws of physics as we know them, because it just bothers me as a physicist to see ideas that do not comply with the laws of physics. But
well, let me interrupt there, because I want to say one thing. But the very strictest definition of science fiction, it must be predicated on science. And if you move beyond the predication on science, it becomes fantasy.
Right, right. So actually, for example, the film Arrival, I liked a lot because it didn't violate the laws of physics. And a few months ago, the producer of Arrival contacted me. We had a Zoom meeting, and he said that he enjoyed very much my book. And I told him that I admired his film long before he knew about my book.
Well, let me thank you for coming on, taking time out of your day to chat with me about this sort of things. And let me say one other thing. He means the film Arrival, not The Arrival, which is a whole different movie. Thank you, Dr. Loeb. I appreciate you taking your time to chat with us about the Galileo project and what you hope to gain from your explorations.
Thank you, Kevin, for inviting me. And I'll be glad to come again once we have some interesting evidence.
Oh, I'd be glad to have you on there. And I did appreciate the invite to your press conference.
Thank you. I should say that on the Galileo Project website, we established a link for crowdfunding. There is a button saying support us. And if anyone is interested in promoting the goals of the Galileo Project, we would be grateful for your generosity. Thank you.
Okay, well, you have a good day, sir.
Bye-bye.
Okay. Next week, I'm going to talk to Mike Rogers, who is part of the Travis Walton experience. We're going to have a discussion about some of the things that are going on with the idea of the alien abduction and what Walton has to say about, or what Rogers has to say about his participation in that. We'll take a long look at some of the controversy that has developed in the last few months about the Walton abduction, which is somewhat disturbing for those of us who have been around the field for more than 10 or 15 minutes. Following that, we'll have Robert Schaefer on board to talk about UFOs from the skeptical side of the fence and see if we can't come to some common ground on that as well. And finally, Rob Mercer, who discovered a great deal of information about Project Blue Book that had been hidden away, so to speak. We'll have him on to talk a little bit about that. That's what's coming up in the future here. Also, take a look at UFOs and the deep state, which I think is becoming a little bit more relevant, given some of the things that have been going on and the discussions of the deep state as it relates to politics as opposed to UFOs. But I think there's some interesting things in the UFOs and the deep state that will get everybody's interest. As I say, you've been listening to A Different Perspective on the X Zone Broadcast Network, XZBN.net. I'll be back in about 167 hours with more incredible information. Thanks for tuning in.